Hi there guys, today I'm going to share a bit of code with you, and today we're connecting our Unity engine to our Arduino just like last time, except this time we're going to use it through a Ethernet cable. Of course there's a serial connected right now, but that's because I'm getting feedback and I need to power the device. But all communication is going to happen through the Ethernet cable. And we're going to use the protocol called UDP, opposingly to the one called TCP, whereas TCP is a more streamlined connection type, and UDP is based on sending a message, just like think of it as a text message from a phone. There are both disadvantages and advantages to both types, but for now we're going to work with UDP because we're working on a local area network, so it's going to be a breeze. First of all, I'd like to show you what this is. Well, last time we worked with this guy right here, and this is the ENC28J60 net encoder, based encoder, so that's the chip, and it's running a different library than this one. You can see in the middle it has the Ethernet shield. This is just an Arduino Uno Ethernet shield and a prototype board on top. This is an Arduino Uno Ethernet module, not shield, and a loose prototype board. Same thing basically, just two different libraries. The code they both use are exactly the same, and I'll show you the difference right now. So here we have our Arduino IDE, and if you followed my previous tutorials, you should have this library called, there we go, UIP Ethernet. And there's an example right there called UDP server. That example is what I have loaded on screen right now, except you can see it's modified by me, January 15. So I changed a few things. Well, first of all, it says UIP like this, so I removed that. I also added this line, the SPI, because these are the two libraries this Ethernet shield is going to use. Everything else is exactly as if I were using, this guy. However, things you need to look out for, I'll include this in the file in the description, are your MAC address. It has to be unique. Your IP, it has to match your network, and we're not using a subnet. And a port. And that's it. So with that said, let's just open a client. Well, that's a bad idea with a white client, so why don't we just close the entire IDE and open PuTTY. Serial connection 9600, and that's on COM5. So here we go. Initialization success. That's just the Arduino responding that it's online. So let's put that off screen right. No, on screen. Off. That's a bit hard because I'd like to have both things on screen. So let's resize Unity a bit. There we go. We have it right here. So I'm going to show you this. It's basically just a transistor, a resistor, and a LED. So when the Arduino is told to turn the LED on, it's going to use the transistor to switch the LED. So here we go. Here's the LED, so you can see. And I'm going to click on, on screen. There we go, and it turned on. I'm going to, it's very hard to see. Yeah, let's do this. Is that better? Going to turn off. Yeah, on, off. And you can see on PuTTY, we're getting the status messages each time I click. So that's cool. Well, then you say, how do we know it's UDP? Well, we'll look into that in a minute. Then I have this update function. So if we turn this on, you can see there's this box on screen. And I'd like to make that a representation of this LED. You can see it's on right now. And I'd like to make sure that those on screen can see it's on in case these items are not in the same room. There we go. Now it's on and this is on. So if we turn it off, oh, the screen still shows it's on, so we can update the status. Well, I have incorporated both functions into one button, and that's this one called switch. So when I click switch, it should switch from current state, which is off, to on, and update the screen at the same time. There we go. And I can do that as fast as I can click, and I can click fast. I can click so fast that the little chicken in the New Zealand story will fly. That's how fast I click. So there we go. You can see it's working great. However, there's only one reason that this is working as great as it is. And that's because I know 100% that the message from the client, the Unity client, is going to be sent to the Arduino server each time. That's one of the downfalls or problems, if you want, with you. Oh, calm down. Using UDP, because in UDP messages are sometimes lost. They just disappear due to electronic pollution, or maybe the wire is too long, or it's losing power. Many reasons. So if the connection is lost or the message is lost, Unity will freeze up. It's just going to stop. And I'm going to freeze it on screen now, just for you guys. So let's just hit save. And you can see I have this nice setup right over here. I think I'll make a different tutorial where I'll show you how to make this GUI, right? So we're going to change this IP to 8. So it's 192.168.1.178. And that's wrong because that's the IP of this one and it's not connected. So we're going to start. And it starts fine. I'm going to click on, and you can see it's going to stay gray for a while, and it continues. It's going to do that again here. Okay, it's still fine. Everything is working. I'm able to use the program, and you can see I can click around, right? I'm going to click update. Either one of these is going to wait for a response from the Arduino, so let's just click switch or update. There we go. And you can see it's gray. And it's going to stay gray. And I can't click anything. And if I open the task manager, you can see right there, Unity is not responding. Now, if we wanted to, we could just wait. I think the default timeout is 3 or 5 minutes, I'm not sure. Then it's going to time out and it's going to return to a running state. And that's because right now we are not using threading. We're not using multiple threads. Unity is running on one thread with our simulation right here. And as soon as we're going to wait for a signal, we're just waiting for something to come into the signal. It's just going to stop and wait and do nothing until it doesn't really matter what the signal is. Any signal. Well, there are a few ways to work around this. You could make the Arduino automatically send a update signal every maybe 5 seconds or 10 seconds. And if you're going to do that, well, then your Unity is maximum going to stall for that time period, at least as long as the units are connected. Another way to do this is how you should and usually would do it is when you code this, you would run this as multiple threads. So and that of course requires a multi-threaded processor, but I don't even think you can buy ones that are not, at least not for PC use. So let's take a look at the code. Well, we can't stop this, so I'm just going to open the task manager again. I'm going to click this and just hit delete. There we go. It has no problems closing Unity because it's not frozen, it's not stalled, it's just stopped. It's just waiting for input. Anyway, here we go. This is our code. It's all compiled into one single script, just for comfort. I don't like multiple scripts. So, script is divided into a few areas, and I'm a real asshole not to comment in the script. So, well, a few things we need. We need these two system.net sockets because we're going to work with the Ethernet connection. And this part is basically just to set up the prerequisites for making the entire thing run. That's the IP address, the port, and see, I have some return port because the return port is running on a different port, and a game object because we want this game object to represent the LED, so we get the light on screen. These two are not used. I just left them there. And this part is probably one of the more important parts. Last time we talked about public voids in the serial connection, and here we're talking about public voids in a UDP connection. Because regardless if you're using NGUI, Playmaker, or in our case, we're not using any assets at all, we're just using Unity as is with its own GUI, we still need to make these voids public, else we can't use them in our objects. So we got 4 publics. We got this one called send UDP LED on, sends a message, and the message it's going to send is actually this one LED off. It's going to send this. And if you remember from our last video with the serial connection, L1 means on, L0 means off. This one is the switch. It's going to send 2 commands. It's going to send L2 and S1. Well, we're only working with L1 and L0, so that's on, off. Well, number 2 is a switch, so it's going to flip the boolean. That's why we're using 2. S1 actually is the command to say to the Arduino, what is your current status? What's the LED? Well, the Arduino will respond. And that's why we have this one. We added a function because you can see these are just send UDP and we're going to send packet data. Packet data is the message. And that's the same for all 4 functions. These 2 down here have a one called receive status. And receive status for S, that basically is a command I've set, so it's going to look for status S in case I wanted to add multiple states. So I could search for multiple things, right? Right now we're just searching for S in the status message. So the return signal with S. So let's look over the code. So far we have two loops or functions we're using. We have one called send UDP and we have one called receive status. So here we go. This is the receive status. We get the character. And we're basically open a client and receiving the status and doing nothing with it. Because this is the point where we get our data. And this point is actually the part where it's going to freeze Unity. And this is the part, this loop right here, you can see I even have a grayed out, is the part that needs to be run in a different thread so Unity can continue to work while it's checking for a message somewhere else. So the things I've grayed out is actually just a catch. It's going to catch if there's no thing connected and there's no response. It's just going to continue anyway, and it's not really going to do anything with anything. It's just going to skip it. So this is sort of a debug loop, but it's working. So that's all, and that is not threading, just so you know. Anyway, we get a byte. We're going to turn our byte into a string because we know all Arduino people love to work with strings. So of course, I'm going to turn everything into strings and work with strings because that's how we do in Unity and C#. So yeah, of course, I'm going to do that in the Arduino as well. And I'm using a new function now called find data. We're going to put in the data and the target letter. And the new function is right here. It's really short. It's just going to check for the letter, run through the entire line, find the letter, and update light search string. So there's another new function. Okay, update light. Well, it's basically just lightball, get the component we dragged into our loop, our public up here. We have this game object lightballs, and change the material color to white, yellow, or white. By default, it's white. Once done, it's going to return. So once this is done, it's going to return, and we're back here. Then it's going to take the UDP client and close the connection. And this loop is done. That's all. So that's all the receive function. So let's look at the send function. And that's a lot like we used in serial connections. And we have it right here. We have this one. We define a MyData byte. And we take our text. That's this one, send data. That's the text we entered up here. The signal that's going to be sent to the Arduino. And we convert it to bytes, and then we're going to pass our IP address and our port, and we're going to define a new connection. Or in this case, it's called the socket, and we're going to say the socket is at this connection, and we're going to use this protocol. Finally, it's going to send the actual data to our new connection or socket. And then it's going to close the connection. So this little thing is going to send all the messages we want just by using these two lines. And then you may say, why are you doing it like this? Well, the reason I'm doing it with this is because if I was doing some sort of GUI where I had a ton of buttons, instead of having to write all this code down here again and again and again, copy paste it, I can just write this code right here for each function I want and change the text accordingly. And it would give me the same result. Plus, it would give me a lot smaller file size. Well, file size is not really a problem these days, but it's still nice to have a small file size. Especially if you're going to export this to something like, let's say, Android or iPhones. This will run on Android and iPhones. So, but I think Unity prevents socket connections on Android and iPhones. So you can't use these two, but I know instead of going out and buying 2000, I don't know, whatever Unity costs, Unity Pro for, I don't even think you can run Unity Pro for Android or iPhone without having Unity Pro Base. I have Unity Pro Base, but I don't have Pro for the add-ons. So whenever I'm using UDP connections for my add-ons, I usually use a plugin. And recently I found a new one. Yeah, this is Unity 5. It's in beta testing right now. It's also working here. The reason I'm using it sometimes is just to test. Is my projects from Unity 4 also working in Unity 5? And yes, they are. Just switching, I think, and even some of the assets from Unity 4 is also working in Unity 5. So that's very nice. But I'm sure they will make sure it won't work for some reason. Well, the reason is money, of course. But let's see. Yeah, there we go. I can see it's loading good old sockets.dll. That's a asset in the asset store for, I think it's $25. And it's going to allow you to use the socket connections on mobile devices without having Unity Pro. That's pretty awesome if you ask me, because that means you're going to save the price of Unity Pro just to enable networking. I know there is something called Photon, but yeah, I'm a gamer and I don't have great experiences playing with games that are using Photon services. I'm sure they're great for some things, but nah. I'm really not a cloud guy. I don't like having things in the cloud. I like to have control. And as soon as I put things in the cloud, like using Photon services, I'm losing control. So, yeah, it's extremely slow to load. And the reason for that is because I think that is a Unity 4 project I'm opening in Unity 5. And even though the project doesn't really contain anything, it's just a few scripts and a asset from the store, is going to try to convert everything each time or check all the lines of code to see if they still comply with Unity 5, and there we go. This is the Unity asset called Good Old Sockets, and I used it in a test. Let's open the code. Yeah. Here we go. Same code as before, but the only difference is it's added these two new namespaces. Well, it's just one namespace, but in front of the system.net and system.net sockets, we now have this lost polygon as a namespace. And well, I think they had some examples, but I usually delete those because who cares about examples, right? If you have any comments, please ask them down below in the description. Other than that, oh yeah, that's my other version in Unity 5. And it's also working, so that's great. Well, can't get this bad boy to update. And I get a few errors on good old sockets. Comment, rate, subscribe, and I'll see you next time. Bye.